Hey guys, welcome back. Let's have a look over a new sensor, temperature sensor specifically, that will be TMP100, and let's visit the website that will be controleverything.com, and here we have to search for this particular sensor and let's see what we got here. And it's a temperature sensor with plus minus 2 degrees Celsius precision. The accuracy will be there, and also a lot of features are on the list, and you can also purchase the sensor right from here. Also, I will be interfacing the temperature sensor TMP100 with a BeagleBone Black, and the software platform I'm using is C code language. And let's go to the resource tab and we can have the C code sample onto the screen, and you can download the code sample right from here as a zip file. That's correct. And also you can get the code from github.com and the concerned repository. There will be control everything community. Now let's have a look over the hardware connections we need to put up together, and let's see how to proceed there. Well, for the hardware connection setup, the first thing we require is the BeagleBone Black, which you are able to see on my screen. And this here is an I2C Shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what do we require is to gently place this I2C Shield over the BeagleBone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this, and gently insert it over here. It is very useful to power up the BeagleBone Black. Now to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently insert it here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. This here is our temperature sensor TMP100, and this here is a connecting cable. Now make the connection among the connecting cable and the sensor, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly has to be the I2C shield. As we are done with the connections for the hardware section, now let's have a look over the code. Now let's have a look over the interfacing part, and here we need to log into github.com, and after that we have to search for the repository that will be control everything community, and let's proceed. And this comes the sensor that will be TMP100, and here we go, and this is the code, C code we are looking forward to explain. But before that, let's have a look over the instructions part we need to carefully fulfill. And here we need to set up the BeagleBone Black, and the steps are on this link, beaglebone.org. As I open this link for you, you can notice a lot of steps need to be fulfilled, conditions, instructions to be carefully examined. And after that, get back to the code, and we have instructions part. We need to download the code onto the BeagleBone Black, and this command will compile and this will run the C code. Note them down carefully. And now get back to the C code, and you notice it's a .c extension file. And the first thing you notice in the code that we have included some of the header files, and in the void main function we have created a setup that will check whether the I2C bus is open or not, and it will also check the device address that will be 0x4f. Now writing section part here comes, and in this part we have to select configuration register having address 0x01, and the command we are going to send is for continuous conversion, comparator mode, and 12-bit resolution, that will be 0x60. And writing part, the command is here. Then we have a sleep function for 1 second, and in the reading section, as you notice, we are reading 2 bytes of the data from the register 0x00, and here is the command. And then we have the conversion of the data into 12 bits, and we are doing so because we have seen the data sheet and it's clearly mentioned the instructions, the formula there. So after that, in the end of our code, we have the output data onto the screen, which you see as the temperature in both the scales Celsius and Fahrenheit. So this is how the code is. Now let's have a look over how it works. Alright, now this is very interesting, which is to show the practicality of this code. And for this part, we need to copy the entire code, as you can see onto my screen, and we need to log into BeagleBone Black, and we have connected it. And here we have to create a new file, as you can see on my screen. It's a .c extension file, and here we have to paste the entire code, and after that we need to save it. And now this is the command you can see on my screen. It's for the compilation step. Here we go, and the code has been compiled successfully. Now to build our code, this is the command, and let's see what we got here. We have the temperature in Celsius and Fahrenheit. Now when I again run the command, the temperature is almost constant or there is a very slight change, which means there is no outer interference or there is no much change in temperature. But when I try to fix or press my finger over the sensor and when I run the command, we have a significant change in temperature regarding the Celsius and Fahrenheit scales. Now when I again run it, you will see the temperature changes that are reflected onto the screen. So this is how the sensor works. Now let's have a look over some of the features, benefit and applications of this sensor. The TMP100 device is digital temperature sensor ideal for negative temperature coefficient NTC and positive temperature coefficient PTC thermistor replacement. The device offers a typical accuracy of ±2 degrees Celsius without requiring calibration or external component signal conditioning. The TMP100 device features SM bus, 2-wire and I2C interface compatibility. The device allows up to 8 devices on one bus. The device is ideal for applications like power supply temperature monitoring, computer peripheral thermal protection, cell phones, notebooks, computers, battery management, office machines and a lot more. Well, you can have this sensor and you can purchase it from controleverything.com and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.